Okay, question 8 from May-June 2022, past exam. This question is on electric circuits. Okay, this is the question. Question 8 from May-June 2022 on electric circuits. Okay, in the circuit below, a battery of a non-EMF and an internal resistance of 0.5 ohms is connected to two resistors of 4 ohms and 8 ohms each and a resistor R of a non-resistance. Ignore the resistance of the connecting wires. Okay, you are given the following circuit. Now, 8.1, the three external resistors are ohmic conductors. Okay, this one and this one and this one. Okay, the three external resistors are ohmic conductors. Explain the meaning of the term ohmic conductor. 2 marks. Okay, an ohmic conductor is a conductor or a resistor which obeys Ohm's law, or you can say it is a conductor for which the resistance remains constant at constant temperature when voltage or current change. Okay, for ohmic conductor, the resistance remains always constant at constant temperature when voltage or current change. Or you can also say the voltage or the potential difference is always directly proportional to current at constant temperature. So you have three options. You can give this one or this one or this one. Now, a conductor or a resistor that does not obey Ohm's law will be known as non-ohmic conductor. Okay, non-ohmic conductor. These are conductors or resistors that do not obey Ohm's law. Question 8.2. 8.2, we are going to solve 8.2.1. Okay, 8.2, when switch S is open, voltmeter V1 reads 3.2 volts. Okay, calculate the current through the battery. 3 marks. Okay, so when switch S is open, now this branch is useless. Okay, this branch is useless. When switch S is open, you don't have this branch. Now, the question is to calculate the current through the battery. Okay, so can you see the current from the battery will be the same current that is going to flow through the 4 ohms, and then will be the same current that is going to flow through the 8 ohms and then back to the battery. This will happen if switch S is open. You are going to have the same current from the battery, and then the same current from the battery will flow through the 4 ohms resistor, and then that same current will flow through the 8 ohms resistor and then back to the battery. So you can use the information that you have on this resistor. Since you have enough information, you know the resistance and you know the voltage. You are told voltmeter V1 reads 3.2 volt. So the voltage across this resistor is 3.2. Okay, so the current flowing from the battery and 4 ohms resistor and 8 ohms resistor is the same current when switch S is open. Okay, is the same current. So we can use the information of the 4 ohms resistor because we have enough information. So we are going to use this formula. Okay, we know the voltage and we know the resistance, we can find the current through the 4 ohms resistor. This is the same current through the battery. Okay, so V1, okay, using this formula, V1 is equal to the current through the 4 ohms resistor times the resistance of the 4 ohms. Okay, so we are going to use this formula, okay, to find the current through the 4 ohms resistor. So you have the voltage 3.2 and you have the resistance, which is 4 ohms. Now you can calculate for the current. So you have the voltage is equal to the current times the resistance. Okay, so to find the current, you are going to divide by 4 on both sides. So you have 3.2 over 4. This is equal to 0.8 amperes. Okay, we are done with question 8.2.1. Let's move on. Let me get the question again. Okay, question 8 from May-June 2022. Okay, this is the question. Now, we still on question 8.2. So, when switch S is open, voltmeter V1, okay, voltmeter V1 reads 3.2 volt. Now, calculate the, now question 8.2.2. So, calculate the EMF of the battery. So, we are going to use this formula to find the EMF of the battery. You have the current from the previous question, okay, 0.8 amperes, and you have the resistance, okay, the external resistance is equal to 4 ohms and 8 ohms, okay, 4 plus 8. This is a series connection. So 4 ohms plus 8 ohms, you have 12 ohms. Okay, remember, switch S is open. So this branch is useless. Okay, this branch is useless when switch S is open. Okay, so you only have 4 ohms plus 8 ohms. Okay, a series connection. And you have the internal resistance, okay, which is equal to 0.5 ohms. Now you can find the EMF, okay, you plug everything into the formula. The EMF is equal to, you can use your calculator. So 0.8 times in bracket 12 plus 0.5, you close the bracket, okay, you are going to have 10 volts. Okay, this is the EMF of this battery. Okay, the EMF is 10 volts. Now question 8.3, when switch S is closed, voltmeter V2 reads 8.8 volt. Voltmeter V2 is connected across the battery. Okay, voltmeter V2 is connected across the battery. Okay, so when switch S is closed, now you have switch S closed. Okay, switch S closed. So the voltmeter across the battery reads 8.8 volt. The question is 8.3.1. Calculate the resistance of resistor R. Okay, the resistance of resistor R. Let me show you this. We can use this formula. Remember, switch S is closed. Okay, switch S is closed. So we can use this formula. We are told the voltmeter across the battery is reading 8.8 volts. This is the external voltage, the voltage supplied to the external circuit. Okay, this is not the EMF. This is the voltage supplied to the external circuit. The EMF is 10 volts. So, because you have a parallel connection, remember, the voltage across each branch is the same. Okay, so on this branch, the voltage is 8.8, and on this branch, the voltage is 8.8 volts, and the voltage for this entire circuit is also 8.8 volts because you have a parallel connection. So, in parallel connection, the voltage or the potential difference is the same across each branch. We have to find the resistance of resistor R. So, the voltage across this branch, you only have one resistor, resistor R. So, the voltage across resistor R is equal to the current through resistor R times the resistance of resistor R. Okay, we are using this formula. So, the question is to find the resistance of resistor R. So, we have the voltage. The voltage is 8.8 on this branch. This is the voltage across this resistor. So, VR is equal to 8.8 volt. Now, you need the current through resistor R. How can we find the current through resistor R? So, we need the current through resistor R. Using the internal voltage, the current from the battery can be found. Okay, we can find the current from the battery, and then we are going to calculate the current through this branch. Okay, so we know the EMF is equal to external voltage plus internal voltage. We can find the internal voltage is equal to, you take this to the left, now you have EMF minus external voltage. Let's find the internal voltage. You have the EMF minus external voltage. You're going to have 1.2 volts. Okay, so you know that the internal voltage is equal to current times internal resistance. So the internal voltage, which is equal to current times internal resistance. Now you can find the current. You're going to have 1.2 over 0.5. You have 2.4 amperes. This is the current coming from the battery. Okay, the current coming from the battery, right? From the battery is this one. This current is going to split. Okay, you have some of the current on this branch, and then some of the current on this branch, and the current will join at this node. Now you have 2.4 again back to the battery. So you need the current on this branch. This is the total current coming from the battery. You need the current on this branch. You have only one resistor on this branch. So let me do this. Okay, remember switch S is closed. Okay, so we have to find the current through resistor R. So what you can do is to find the current on this branch, because on this branch we have enough information. Remember, the current through the 4 ohms resistor is the same current through the 8 ohms resistor. Okay, so we can find the current on this branch. Okay, we can find the current through the series branch. We are going to call it series branch because we have a series connection. So the current flowing through the series branch can be found. Okay, and then we are going to subtract from this. The remaining will be the current on this branch, the branch with resistor R. So we are going to use this formula again. We know the voltage on this branch is 8.8 volt. Remember, you have a parallel connection. The voltage on this branch is the same as the voltage on this branch, 8.8. So we can use this formula to find the current on this branch. So the voltage on the series branch, okay, the voltage on the series branch, we have a series connection. This is equal to the current through this branch, the series branch, times the resistance of the series branch. Okay, you have 12. Okay, 12. Okay, on the series branch, you have 12. So you have the voltage is 8.8 on this branch. This is equal to the current on this branch, the series branch, times the resistance, which is 12. 4 plus 8, 12. Now you can find the current on this branch. You are going to divide by 12 on both sides so that you can solve for the current on this branch, on the series branch. So you have 8.8, you divide by 12. Okay, you divide by 12 on both sides so that you have the current through the series branch. So this is equal to 0.733 amperes. Okay, now you have the current through this branch. So now the current on this branch, we can find it. Okay, the current flowing through resistor R can be found. So you are going to have the current through resistor R is equal to total current minus the current you have on the series branch, which is 0.733. This is equal to 1.667 amperes. Now you can find, let me do this. Now you can find the resistance of resistor R using this formula. You have the voltage, you have the current. Now you can find the resistance of resistor R. So the resistance of resistor R, you are going to use this formula. You have the voltage is 8.8, which is equal to the current 1.667 times the resistance of resistor R. So the resistance of resistor R is equal to, you are going to divide by 1.667 on both sides. So 8.8 divided by 1.667. Okay, you are going to have 5.28 to 2 decimal places. Okay, 5.28 ohms. So this is the resistance of resistor R. You can also solve this question using this method. Okay, this is an alternative method that you can use to solve this question. So use the external voltage and the total current from the battery to find the external resistance. So let me show you. Okay, you have switch S is closed. Now you can use the external voltage, which is 8.8, and total current, which is 2.4, to find the external resistance. This, when you use the external voltage and total current, you are going to find the external resistance, and after that you can find the resistance of resistor R. So you have this formula for the external voltage. This is equal to current times external resistance. So you have the current from the battery. Okay, using the internal voltage, you can find the current from the battery, as we did in this question. Now you have the external voltage, which is 8.8. This is equal to, you have the current from the battery, 2.4, times the external resistance. Now you can find the external resistance. You are going to divide by 2.4 on both sides. This is equal to 3.667 ohms. So this is the external resistance. Okay, the external resistance. Now you can calculate the resistance of resistor R. Okay, so using the parallel connection, find resistance R. You have the parallel connection. So using the parallel connection, you know 1 over this. Okay, the total external resistance is equal to 1 over 12 plus 1 over R. So this is the formula we use when we are calculating for parallel connection. You have 1 over Rp. Okay, 1 over Rp. You can calculate the resistance of resistor R. Okay, so you have on the left, you have 1 over 3.667. You bring this to the left, you have minus 1 over 12. Okay, 4 plus 8. Okay, so you have this on the left, you bring this to the left, you have minus over 4 plus 8. You are going to have this 0.189. This is equal to, you only have 1 over R. So to find R, you are going to flip. Remember, this is over 1. Okay, so you are going to flip. You are going to have R over 1. You have R. This is equal to, you are going to have 1 over 0.189. This is equal to, you can use your calculator, 1 over 0.189. You have 5.29 ohms. Okay, so can you see? Now let's move on. Question 8.3.2. The battery becomes heated when voltmeter V2 is replaced by a connecting wire. Explain this observation. Explain why the battery becomes heated. Let me show you. Let's get the question again. So, when you replace voltmeter V2 by a connecting wire, So you have a wire there. Okay, you have a wire. Instead of a voltmeter, you have a wire. Now the battery is heated. Explain this observation. You have to know that whenever you are connecting the positive and negative terminal, okay, whenever you are connecting the positive and negative terminal, or whenever you are connecting two different terminals, you have to know that you are going to create a short circuit. So this is the same way as connecting another branch. Okay, you are creating a parallel connection. Remember, in parallel, when you are creating more branches, you are reducing the resistance, okay, while increasing the current. So the total resistance is decreasing, and whenever the resistance is decreasing, the current will do the opposite. So the current delivered by the battery is very high. So you have to show this mathematically. You have the current is inversely proportional to the resistance. This is how you can write inversely proportional to the resistance. You have 1 over R. Current is inversely proportional to the resistance. Whenever the resistance is decreasing, the current is increasing. Okay, you can see whenever the resistance is decreasing, the current is increasing. Okay, so total resistance decreases, current delivered by the battery increases. Okay, is very high. So because of this, you have higher current. Okay, higher current produces more heat. This is why the battery is heating. Okay, so we are done with this question.